This is the print for manufacturing. So thinking about manufacturing, what happens after the manufacturing? You have a product that in the end, the producer of the product is selling. And that's why I said, look, when I look to my portfolio, I can talk about water-based things, but probably many of you will already do that, which was the case. And water-based inkjet is growing, definitely. But UV is there to stay for many, many years, because we're solving issues with UV. And looking back to all the projects I've been involved in since 2007, there was indeed, like Marcus said, there was a hype on direct-to-object, direct-to-product printing that was a bit stabilized, but it's really picking up. And that's why I've chosen to go for that. So this slide, AGFA has different things in Inkjet. My head is working, collaborating with the industries and the companies building printers that need good chemistry. That's my role. And when you look to UV ink, I'm not going to explain this and just use this a little bit as an eye-opener, why UV is that strong. By the chemistry itself, you get a lot of consistency. And that's one of the key advantages of UV. Adhesion, often without special things, not always, but you can have it. The durability against scratching and all other stuff. Instant dry. And UV ink chemistry might look positive here, but in fact it's a concern. Because of the reclassification, it's getting more difficult. But by playing with the monomers, you can tune the flexibility or the rigidness of your ink, for instance. There's a lot of toolbox that you have. And basically the toolbox is that every single compound in your ink chemistry affects all aspects. That's what you need to learn when you go into UV inkjet. Beginning you don't know, you learn that. Every single aspect is influenced by every compound in the ink. And that is what you need to tune to certain applications. And looking into direct-to-product, you have a market pull, hopefully, and you have a technology push. When you only have one, you have no sales. You might have a fantastic product, it's not selling. You might have a very interesting project, market, but your solution is not working, you have nothing. So I will not talk in detail about this, but I will go to some cases. Some of them took years to fly. Some of them took not days, but a few months to fly. Really, when you have a solution that works, that profits from the digital part, not only from waste, but quality and so on, it can go fast, but not always. I will go some cases, and some that I will not show. For instance, the do-it-yourself spare parts. You have this do-it-yourself machine, the system, you need a new razor blade or whatever, a saw blade. You want to be sure that you buy the right one that fits in your system. Inkjet print on the saw blade. It's happening today, as an example which I will not go into detail. So there are a lot of enablers in UV inkjet that make it happen and that have evolved over time. Like, for instance, the high throwing distance. And I will give a few examples of that. Only possible when you tune ink, the printhead, the waveform as a combined thing to bring the solution. But it really works. Very important. And of course, there is a lot of technology behind that we need on how to handle the image, how to handle the curvature, the structure of the substrate, of the object, and pre-treatment, already explained by Plasma Pete. Thank you for that. Important. Of course, there are alternatives. There we also have a UV curable, LED of course, a jettable primer that you only jet where you bring down your ink on top. Can also be a solution. So there are often sorry, many options to go. But there is typically one really option that combines result, technically, and commercial. Okay, first one, automotive. I'm really happy that the next event will not be here, but will be in Auto World. Because then we really need to have the industry of tier 1, tier 2 suppliers to the automotive. They're all looking into Inkjet. Not all of them understand yet. So we really need a forum to explain to them what we can do. So the sun visor. In the old days, it was a label. Printed offline, label was sticking onto the material of the sun visor. Now it's replaced by direct printing. And what is the key element here is the white ink. It needs to be very opaque white, as cheap as possible. So here we use a very high opaque ink, that the print is very opaque. We have reduced the amount of ink by 50% by having an opaque white ink, which is not sedimenting, by the way. 18-month shelf life and no sedimentation, 0. By the formulation. It's printing on a specific textured substrate. Needs to be durable. Inside your car can get very hot. Your car gets very old. And it's printed in an environment where it needs industrial reliability, and the shape and the forms and the curvature of all the sun visors are different. So also your system needs to handle that. Secondly, maybe something trivial, but narrow band. There's a lot of narrow band in the world. In textile, it's typically water-based ink. You have skin contact. But this one is in transport, the tension straps. What is special here? It's a Belgian company, by the way, ICS, has built a system using Toshiba Tech Head, I should say Riso Head now. And what you don't see here is that 2 seconds after printing, it's rolled up. So you can say instant dry, but does instant dry really mean that you have no set-off? In worst case, even sticking of that ink to the backside. It happens when your ink is not okay. So you really need very high density black. Really, that's what they want. It should look appealing. There's some messaging on there. There's some advertising on there. And you need that. This is rather clean environment, this case, but often it's in a dirty environment. A lot of dust. Uncontrolled conditions of relative humidity and temperature. Freezing in the winter. It can happen in these cases. So a real industrial application. Not so easy for the ink. Then a Spanish-based integrator, Limitronic, where we work for many, many years. And they always try. And I really like this one. It's only to be there for 3, 4, 5 months. So it's not really about outdoor stability. It needs to be durable for the time the image is needed. Because what do they like? They like to actually print something new on it. So what often happens, they print white over the previous print and then again print black on it. Because they reuse the cables for different. It's too expensive, the cable holder. So they don't want to throw it away. They want to use it again. Yeah, our ink is durable, so just remove it by a knife, it's not going to happen. It's there to stick. So overprinting and then a new image on top. This one, all those electrical components, very difficult. Those substrates are actually ink repellent. When you print without pre-treatment, you have nothing. I see Peter not. Here you live by the pre-treatment. So every single integration is a project, but 3 times the same ink. That is the key of the story here. You don't need to change the ink. You change the process. You learn what is before and after in the manufacturing, and you make your ink work with that. That's the key element. So there's a lot of application research on it and approvals by the end user. That's the key story in this type. With one ink doing the multiple things. And now something really different. A French company, AGFA. It's artificial leather. So it's not real leather. Polyurethane. The white ink, the same white ink actually as the one on the sun visor. Again, high opacity, needs some flexibility. Durability, of course, because you're walking on the street with it. And it's kind of a textile polyurethane. It's something combined because it needs to fit very well. It's a sports shoe. LED curable, of course. And there are a lot of process steps. If your ink adheres well, but after the final process you lose it somewhere of the lamination, you have not a good ink. So these are not easy things. It takes a lot of time. This took years. And then I come to one of my favorites, which is changing the industry. So how is this done today? Today, this is all hot iron branding. So what does it mean? You are in a wood factory. Some guy is there burning, and he's not holding always the iron plate correct. So sometimes the readability of the EPA logo is terrible. It takes forever. What we do now is the printer is in line of the pallet making. There are two options. You print on a block, and then the blocks are used to make the pallets. You can still make a mistake that the print is on the other side. But when you do it on a pallet in the factory, then it's really a game changer. And EPAL, this company, originally Dutch, now based in Poland, he has an agreement with EPAL, and the barcodes are readable. So what is special about this ink? The black density, as you can see, and it's jetted from 20 millimeter in skyscraper mode with a Toshiba Tech head. In the plant, so the wooden pallet is outside, they take it inside, they print, and the next day it's again outside. It's very tough for your ink. But really a game changer. And here this is a very nice case of technology success and market success. Why? This guy knows the whole industry. Every single producer of pallets, he calls them friends. So here you have the access to the market, and you have the access to the technology. It took some time, but now it's flying. A really nice example. He's doing other stuff on boxes, on wooden boxes, but his main business is the pallet industry. Huge industry. Last case. Also a very special case. IIJ, not far from here. I see I still have the old logo. They changed their logo last week. It's a more, it's a different blue. It's less blue. The project here is with an ink that is IKEA approved. So there are no carcinogenic, mutagenic, reprotox compounds inside. You have two choices. Either you have standard CMYK, either you have a special color, which we call wood yellow, wood red, for low metabolism, which has a color gamut to reproduce all kinds of colors. So what they do, the company buys always the same type of hardwood. Cheap, regular, good available, not something critical that is expensive and difficult to get and kills rainforest, no. And then they stain, as they call it, always to the certain color they want. And this is for chairs, but it can be tabletops, all kind of furniture, where they stain into the specific wood color that you would like to buy. But it's not that wood. It's another wood that you stain to look like the wood you want for your living room or so on. So that's really something, and it's curved, and I can tell 15 minutes about this one because there's a lot of technology in this, about handling, because it's not a flat surface. And it has to be printed on all sides. So automation, robotics, and so on. And then something I don't focus today on, but it's one of my major business growths, is the edge band, is all kind of stuff, interior decoration. It's all about, again, IKEA compliant. Even if the customer is not selling to IKEA, they want IKEA compliant ink. So there is a huge booming in this world of UV inks, direct to wood, ABS, edge band, and so on, where there is a lot of demand of wood colors, so with low metabolism. So that's a huge business for us. When we talk to automotive customers, we're not only working with them with integrators selling systems to print inkjet on parts, which can be functional parts or interior panels, but they also want to decorate the ceiling of the car or the seat or of a bus, and that is then often G9 leather. It's not fake leather, it's real cow leather, and AGFA has a patented system called Alusa, where you have a combination of coating and UV ink to give flexibility. You can do this 200,000 times and the ink is still not cracked by that combination. It's quite unique. Last but not least, you also have a lot of functional inkjets happening. That's not so visible in conference like this. I'll touch a bit today, but printed circuit boards typically is a very bad chemistry. It's a lot of waste, a lot of process steps. There's a high cost of doing that. For instance, the solder mask. You can get rid of 50% of the steps and a lot of waste by doing it by inkjet. And this is something where AGFA also has a specific team to do. And one of the side effects of that was that we also have, with an edge resist ink, can do some metal structuring for nameplates and parts in the car again. So the advantage of this is that when you talk to that world of automotive, you have 3-4 different inroads to them to offer just more than a nice plate in the car. And I don't really make a summary to be on time.
Yeah, very good, very good.